In this lesson, I'm going to show you a few worked examples on auxiliary views, right, from past papers. If you look at this view, we've got a front view and a side view of this anchor shape, which is a prism. See, this is the front face of the anchor shape, this is the back shape, and they're identical. And prisms, when you have prisms in this manner, in an auxiliary view, they're much simpler to work out than different auxiliary views. All right. So this face gives me the XY line. So this question has the XY line here. That's the measuring line. All right. You're going to use that to measure from. And then you've got another XY line in the auxiliary projection up here, which you're going to draw it on. All right. So you take measurements from here and construct it here. All right. This angle is always 90 degrees to the projection angle of the auxiliary view. So if it's 45 degrees projection lines, you get 45 degrees the other way to get perpendicular with the projection lines. Now what I've done so far is I've already projected from the front face. Projection lines from each detail, from each point I have. So if you've got this corner, which is this, I've projected a 45-degree line onto the XY line. I've taken the front face because the arrow is looking at the front face. So I've projected the front face first. That's the most visible point. Don't project from the back because most of the back is going to be hidden. So I'm going to take points from there. Now what you need to do is take each point in the front view. So let's say that point. Find where it has been projected, that's that point. And on that line you have to measure at that point how far it is away from the XY line. Now this point is exactly on the XY line, so I'm going to mark it exactly on the XY line. Now here I've got a curve. I need some points to find that curve. But if I need this point, the end point of the curve, which is this point, on this line, I'm going to measure using compasses the distance of that point from the XY line. So I'm going to take distances from the XY line, perpendicularly from the XY line, always measure perpendicular. Taken on that point and measuring this way and that way. These 2 points are these two. If I need to find the curve, I have to add extra points to help me find how that curve is made. So I've taken an extra point there and an extra point there. This distance, this point is that far from the XY line, and I'm going to take it there and there. This point is that far away from the XY line, there and there. So if I take a freehand curve now, I'll get that curve and that curve. Now, obviously the more points you take on the curve, the more accurate you'll be to get that curve. So each point, now I've got this point here. So I'm taking point by point around the shape of the anchor, and each point I'm measuring how far away it is from the XY line. So I found this point. To get this point, I'm going to use the same projection line I used for the outer curve. That distance from the XY line, there and there. I'm going to take another point here. So this point is that far away from the XY line, there and there. This is where the curve ends, which is on this line, again perpendicular. So far I've got there freehand curve, straight line. What's the difference between this and this? This has been shorter because you're looking at it at this angle. This is its actual length, but here it's going to be a bit squashed. So what I'm going to do now is just continue the points. So I finished these 2 points, I'm going to do these 2 points now. That far away from the XY line. Here, it's the same distance as here, but up here. And there. On the same line I've got these 2 points. There and there. I prefer to join a few points at a time than all at once, so as not to confuse the sequence of points later on. Once you get an idea of how the shape is going to plan out, some of the points are a bit obvious. So this point would be exactly above this point and this point, but here. Alright, here these 2 points is where the circle starts. Got one there and one there. Now to get the circle, I need some points to help me project it. So the circle is going to start here, it's going to end here, at this point here, and its diameter, thickness, that's the outer thickness of the circle. So it's going to start from here, down, there and there. I could use extra points for the circle to help me get a better freehand. So a small circle like this would be enough to have an extra 4 points projected to the front face, and then find the perpendicular distance for that. But for the sake of this exercise, I'm just going to draw a freehand curve there. The same way you'd need to find the inner circle. So that's the top 2 points exactly on the XY line. The distance, the thickness of the circle is taken from here, that way and that way. So for small circles, there's no need to get 12 points like we usually do with a circle. That would be enough. So that's the front face of the prism. Now to get the back face, alright, to show that this is a solid, not a flat face, you have to do the same thing, repeat the same thing, but from the back face, here. So repeat the same thing from the back face, and you'll get the bottom corner here, which would be shifted a bit downwards, and you'll get the same shape, shifted slightly downwards. And you repeat the exact same procedure. Otherwise, you could do, and I prefer this method, much easier, you can do this. So I'm just going to take 1 point, but it would be, this point would be the bottom point. I'm taking this point with 45 degrees and project it onto the auxiliary view. So the front point is here, and the back face gives you here, which means that this is going to show the thickness of that distance. So what I'm going to do is I'm going to take each point that I've already found from the front view and project it downwards. Now when I say downwards, I mean the same angle as the XY line, not vertically downwards. So each point is going to be shifted the same amount as I found here. Now using the compass, I can shift each point downwards to give me an exact copy of the front face. And what I get the same shape, but shifted downwards. That gives you the depth and gives you a false 3D. So that's the auxiliary view. So I've taken one distance here and then repeated it the same angle, not downwards, the same angle as the XY line to give it a 3D shape. Now that was the easiest kind of picture where you've got a prism-like shape. Let's say we've got a more compound shape. Say like an example like this. So here we've got three views, front, side and plan. Now instead of having the side and the front and we're projecting, we've got the front and the plan, and the XY line now is horizontal since we're taking two views. Two vertical views, the front view and the side view, and we're projecting at 30 degrees from this view, right? So when you have a front and a plan, the XY line is going to be horizontal, not vertical as it was in the side view. Here we've got the XY line where we're going to project our view, our auxiliary view, which is at 60 degrees because this is 30 degrees and it's going to be perpendicular to it. So what I want to do now is project lines taken from this view.